Hello everyone, thanks for joining me again today. During today's session, I will probably be attempting to resolve the problem we spotted the last time, and that is the maxXs. What it means is that we need to make sure that at the time of rendering a block, the max excess of the previous block is known. And I'm not really sure how to resolve it yet. So this session probably is going to be me trying to figure out what the best way around this problem is. But we'll see. Anyway, I hope you have your drink of choice ready. I got myself a cup of coffee. It's the last session of the week. Where I live, it's a very gloomy, sad day. But I have my code and I have my diagrams and Haskell, so I'm reasonably happy. Let's rerun the solution. You can probably tell that I have a .NET background. Let's rerun the project just to illustrate the problem. Yeah, the collection of maxXs is just one element long, and it contains only this guy. You know what, let me take a quick break. I'll be back in a second. Okay, I'm back. Looks like OBS is still rolling. All right. So maybe this is going to be a naive exercise, but sometimes you just have to break things up into smaller pieces and investigate like that. Let's try to trace where the maxXs is going as we render. So the wyvern diagram, this is the starting point of the application is called from here. And we render left to right, which is good, or top to bottom in that visual, sorry for presentation. We start with maxXs being 0. Oh, sorry, not 0, nothing. We go to the first block here, blocks. So the first block we're going to render is this question. Let's simplify the input a little bit. So we'll get rid of this question, action 1, action 2, action 3, action 4. We're just going to replace it with just one action. It's called action 1. This we can remove. This we can remove. Much easier to track, and we still retain this connection that needs to go from action 5 to question 1. And let's check if it's correct. 3 minus 5, 0, 3. Oh, here is 3. Minus 5, 0, 1, 2, 3, 4, 5. Correct. And question 1 is, I'm not looking left, looking right. 0, minus 1. 0 minus 1. Okay, perfect. Oh, and before I forget, let's remove that part. This is not correct. Would this be better? Oh yeah, it will be better. Yeah, this empty list is gone now. So you know what? Let's take not one but 3 steps back. Threading that maxXs through the entire collection is a very appealing idea, but maxXs will not be formulated until we finish. maxXs for a question will not be finished until we get to the very bottom of its structure. It's maybe not ideal, but this is the way things are. So I'm not going to remove it yet, but instead of maxXs, I'm going to use tuple data structure that pairs the maxXs value and also a string that is the content of the block which maxXs we're looking for. If the maxXs corresponds to the block, and I don't see a reason why it shouldn't, we're probably going to extract a function or a family of functions that just sweeps through the blocks once before the rendering is done, just to get an idea of where the positions would be if we had no connections. That is probably not going to be the most performant or ideal long term, but at least we'll have something to stand on when building these gamma connections. Okay, maybe there is a way to simplify this later. I don't want to start running before I learn how to walk type of situation. So indirect gamma connections, let's leave in place, but instead of doubles here, let's change it to a string of them. And if this renders satisfactory results that illustrate the pairing block, its max length, we're just going to extract this into its own individual sort of pre-rendering paths of all the blocks. So I'm going to cheekily only update the types, not variables. variable names, sorry. Because I know that these two functions, render and render prime, do not alter themselves the maxXs. What does update maxXs is a dedicated function. Thank you, past me, for doing this. So here we do string, and we return the same type. To these guys, we simply pass in C. This we can, oops, remove now. I would love to know what I'm doing today. It's been a long week. So we can just do and in main we print it, so it should handle tuples. Let's run. So update gamma, of course, update gamma connections also is getting maxXs. How should we call maxXs? All right. So what do we have here? It goes right to left. So start 1.5, that's maxXs. Oh, that would, oh, sorry, I'm not sure why I'm calculating it like that. It's not half of the defined bounding box length width, it's the whole thing. Oh, no, that is much better. So start is 3, this is 3. Oh no, sorry. No, it's all fine. It's all good. I keep forgetting that 0 is here. 0, 0 is here. Apologies, ignore me. Okay, so start 1.5, correct. Action 1, sorry, 1.5, correct. Action 2, 4.5, correct. Action 3, 4.5. Action 4, 7.5. Action 5, 4.5. No, that's not right. See, for action 5, I would expect 7.5. So while action 2 is correct, because there's nothing to the front, to the right of it. Action 4 is correct, there's nothing to the right of it. But action 5 is not correct. Because if we wanted to go back to question 1, we would have to go past this. So this is 7.5. So let's leave this comment here. '24th. So I know we can't connect AND with anything using a gamma connection, but it should still be 7.5, and action 5 should still be 7.5. So it looks like we need a function, something like render, that captures these maxXs, or maxX. So let's take this render as an example. And let's call it scout. It takes in its minimal form, just blocks. And this, because we'll be calling it from probably Scout Prime. Okay, excuse me for a second. I'll be back shortly. All right, I'm back. Now, this function Scout is going to be very similar to render. And here I'm not saying I have the answers to every question. I'm just exploring. We'll probably also need the origin here. Oh, but we don't need a diagram, which is good. Because here we don't render anything. We don't need this, we do need this. Origins, we don't need. I don't need this. Not this. Not this. And this also goes. And here we only return maxXs. Now instead of render prime, we'll have scout prime. Let's borrow the definition of render prime of start terminator. We only need block, origin, don't need origins. We need this, and we only return maxXs. So we can probably squeeze all of this into one line. Oops. Okay, excuse me for a second. I'm back. The nature of my day is that I need to be available in many places at the same time. And I left my coffee downstairs. Excuse me for a minute. Okay, back again. Apologies for all those interruptions. We were here. Scout Prime. This works the same way. Now actions, headlines and addresses. So at the end of this session, if I see a correctly rendered collection of maxXs, I'll be happy. And finally, fork. So fork is going to be a little bit tricky. Let's leave it commented out for now. But we can uncomment this into scout prime block origin maxXs. That's it. Now let's try to figure out how fork would work. We don't need this. We don't need this or this. I don't know if we need this. For now, underscore. Let's just try to simply build it now. One error, let's see. I'm horrible with these indentations. This is what I usually do, and I let the linter figure out the correct positioning. I will just never learn. So this compiles. Anyway, now update. Let's just try to call it. From here. Okay, so we only have one top level skewer. Not the end of the world. origin. That works. Let's see what we get. Of course, incorrect result because questions are not finished, but let's see what we get still. And question start. Okay, so in a question, we lose everything that the question owns, which is most of the diagram. Okay, let's correct it now. But so far, it's going well. So fork on its own does not do update maxXs. It calls the scout. Origin. Left origin, right origin. Every time we use this with function, it sort of fills me with anxiety. But we'll see. For now, we're just exploring. Yeah, the more I'm looking at this with L, the more I think we should get rid of it. But I don't have a good idea what to replace it with yet. So we'll see, I suppose. So technically, I think we should explore the right-hand side first. Okay, let's see what we get. New maxXs. Start correct. Action 2, correct. Action 3, incorrect. This is not going to work. Because following this thinking, if we wanted to check the max success of, say, left-hand side branch of question 1, it is still going to be the max success of action 4, and that is incorrect. I think I should scrap this whole idea of max success and just render connections as they come. I'll have to think about it some more. Because technically nothing's changed here. Whether we render right-hand side collection first or left-hand side correction first, we're still getting the same result. And if we try to override it, we'll override it with the wrong version or with the wrong value. Action 3 will become 7.5, and that's correct. And action 5 will also become 7.5, but action 1 will also become 7.5, and it shouldn't be that. Because the maxX on the left-hand side branch, in our case, is 1.5. Yeah, I think I'll have to think about it. I don't want to finish this refactoring because that, I feel, leads us nowhere. I think we'll have to just bite the bullet and start rendering, or at least formulating gamma connections as we formulate or render their starting blocks. Anyway, whatever happens, we'll experience it all together. So thanks very much for your attention today and for sticking with me. I'm having a lot of fun with these diagrams and writing Haskell. Yeah, I wish you all a fantastic weekend ahead. I hope you recharge your batteries and spend some time with your loved ones and with your family and friends. And I'll see you next week. Take care. Bye.